Okay, so let's resume the plenary session, and we're going to have a panel, AI Security and Research Cyber Infrastructure panel. Our moderator is Anita Nikolich. She's a cybersecurity researcher at the iSchool and a very, very, very well-known longtime friend of Trusted CI. Anita, welcome.
Thank you. So I'm going to introduce our panelists, and then we have some prepared questions. So I'm going to ask them a question each, then we're going to have some audience interaction. And to set the stage, this is a confluence of a couple of topics, AI security, research security. It is not about using AI for security, so keep that in mind. So I'm going to introduce our panelists, and thank you to all of them, by the way, for participating in these this year of thinner budgets. So Dave Hart, who's right here on my left, Dave Hart has managed the allocations process for NSF's NCAR HPC resources for the past 15 years, and he's the co-PI for NSF Access Program's allocation service. He served in a number of leadership roles in NSF Cyberinfrastructure program since 1995. As part of his efforts with NSF Access, he's the allocation working group co-chair for the NAIRR pilot project, which we're going to talk about. So he's helping to connect researchers to a wide array of resources to support their AI activities. The NAIRR pilot, if you're not familiar with it, has fielded nearly 1,000 proposals since January 2024. Next, we have Dr. Gabriela Ciocarlie. I'm sure I messed up her name. She's an associate professor in the Department of Computer Science at Stevens Institute of Technology and the acting CTO for Cy-Mantle. Her expertise is in anomaly detection, network and application level security, and cyber physical systems and trustworthy AI. Before Stevens, she was an associate professor in ECE at University of Texas, San Antonio, as well as the chief product officer at Alpha Secure, and a senior technical manager of SRI's New York City Research Hub, focused on cyber analytics, which she established in 2016, which is when I first heard her name. She's received multiple awards, such as the Bronze Stevie winner, Woman of the Year for Government or Nonprofit in 2020, and IEEE Golden Core Award 2025. And next, sorry, we're out of order here, Mike Korn. Mike is a long-time friend of the summit. He's a career CISO, has been a CISO at several major universities, and was formerly the cybersecurity advisor for research infrastructure at NSF. He's currently an executive strategic consultant at Vantage Technology Consulting Group, as well as a cybersecurity consultant for the Association of Universities for Research in Astronomy. He also authors a very interesting monthly hotline column for EDUCAUSE and runs a great Substack, which has a lot of provocative thoughts.
I'd like to point out that she added the word interesting in there herself. That was not me.
So a wide range of backgrounds for our panelists. I'm going to start with Dave. So Dave, you're working a lot with NAIRR and the NAIRR pilot. This is, the theme of the NAIRR and the pilot is to democratize access to compute resources for AI research. So you're running allocations for this. How is the NAIRR team dealing with kind of the security trade-offs between openness and innovation and protecting, sensitive data, sensitive models in a shared infrastructure?
So that's an interesting question because in short, the basic way we handled that is to not deal with those kinds of data sets. The NAIRR pilot started with several legs. One was called NAIRR Secure. One was NAIRR, what we call the NAIRR pilot's the main part of the thing that's most open to many researchers. It includes classroom allocations, typical research requests. For a while, we did have support from some cloud vendors who offered secure enclaves for research projects, but the two vendors, Amazon and Microsoft, have paused their awards to small projects at this point. And at the moment, we can't really support a project that wants to come in with a need for any data. Certainly HIPAA is well beyond, but even CUI, PII, anything that requires a secure enclave, there are really no opportunities for researchers at this point, save a brand new one from that I have to remember the words, it's so new. The National Center for Science and Engineering Statistics has an enclave they've made available to do some analysis, statistical analysis on otherwise secure data sets. That's the only one opportunity at this point. The way NAIRR Secure handled it, that was run by NIH and DOE, is they did not have an open solicitation for proposals. They did full funding proposals for NAIRR secure projects, demonstration projects, which they then funded to work at Oak Ridge National Lab on the Frontier system, which has a secure enclave. So there are a handful of such projects that have been funded so far through NAIRR, but otherwise we have mostly dealt with open projects that do not need any sort of HIPAA compliance. So it limits the kind of medical research, for example, that a number of researchers want to do that it involves patient data, for example, is just very difficult to support right now. There are some limited pieces you can do, but obviously data is the problem, and secure data and use of secure data is a current problem on the NAIRR pilot.
So Mike, with more of these, NAIRR and more of these kind of AI workloads and AI-enabled systems, you come from a traditional kind of CISO, enterprise, campus security. How do the security assumptions, controls, frameworks around traditional enterprise, campus, R&E systems, how do these differ, or do they, when you apply them to this new kind of AI-enabled workload?
So there's a couple ways to look at this. I think the critical thing is I'm not going to suggest that people throw out their existing practices. You need to bring your traditional cybersecurity expertise and controls to these environments. They are computers running on networks, running software, and everything you've been trained on and everything you've done is still applicable. But I want to give you an analogy that I'm fond of making in this regard. And the analogy I'll make is to the physical sciences. When it comes to looking at the most basic form of sort of reality science, we're talking about physics. And physics has a set of rules that governs how things work. And we use it to make predictions about how the universe works. You go up the stack to something like chemistry. It's true that modern chemistry depends a lot on physics, but there's a whole body of rules and sort of equations and techniques for making predictions about chemistry that don't depend on a deep understanding of physics that's been around for a long time. You go up the next stack to biology, same thing happens. You have an entire set of tools available to you to make predictions about how biological systems work. And of course, when you get to human society, everything's off the table. It completely breaks with the past. The reason I make this analogy is I think this is what we're facing when it comes to AI. Yes, you need to bring those traditional tools to your AI environments, whether you're talking LLMs, which is all the media talks about, or any other form of AI, but there are emergent properties and behaviors that come from these AI systems that are really novel and unpredictable. And by emergent, I mean that they depend on things that we can't anticipate based on the elements that make them up. So the way I look at this is we are entering a whole new world where you may not even be able to predict what kind of behaviors your AI systems are capable of. And think about how difficult that makes it to predict how attackers are going to use them. With some of these systems, think about if we go to the LLM world again, you've got prompt engineering as an entire sort of art form now. Well, how do you deal with prompt engineering and entry validation when almost anything is possible as a prompt to get your LLM to behave in a certain way? So what I like to remind people of is, yes, again, bring all those traditional tools and frameworks to the table, but to go back to a term that I really like, epistemic humility, we have to acknowledge that there is a lot we don't know, that we can't know about these systems. And I think it's very important, no matter how sure we are in our expertise, in our knowledge, in our confidence in our tools, that there are things we cannot anticipate. And that takes a really different posture to the problem. I'm not even quite sure we have a good understanding of the threat models that can come from this at this point in time.
So that's a good segue to a question I'll ask Gabriela. And I'm seeing more in the past week or two about kind of AI in the physical world. So you deal a lot with cyber-physical systems. So as AI is taking over decision-making in physical processes, what new attack surfaces are you seeing that are being created that traditional ICS, CPS security frameworks don't address right now?
Let me start with the fact that I'll focus a little bit on the manufacturing systems. Cyberinfrastructure, for which I'm the CTO, is an institute that focuses on cybersecurity for manufacturing systems. It's a DOE-funded setting, so I'm going to bring a lot of my examples from there. So let's think a little bit about all the different AI capabilities that people are using today. For example, they are using AI for manufacturing systems to do optimizations, potentially to do anomaly detection. And when I'm saying anomaly detection, think about anomaly detection not necessarily from a security perspective, but from the parts that can be malformed due to certain faults inside manufacturing systems. Security comes to picture as well, because attackers can act as faults in the system as well. So I think that when we talk about cyber physical systems, there is a close relationship between safety, security, faults. So all the different capabilities that are going to be deployed in these systems are bring different ramifications in terms of security. So as I was saying, we have a lot of people that are doing anomaly detection with different attacks. Let's not forget that Hugging Face, which is one of the biggest AI models, have been proven to have models that have been compromised. So imagine now that you are doing optimizations for an industrial control systems with an AI that has been compromised and is not going to optimize, it's going to actually draw more energy or do parts that are not going to have the integrity that you need, and suddenly you have some sort of an engine of an airplane that has been compromised because the tools that have been used, the AI that has been used, is not correct, and it's going to give the wrong parameters for that particular engine. So these are the types of opportunities that we have to secure these systems and to secure the AI. Now let's move forward to other types of AI. Digital twins. Everybody's talking about digital twins, right? And yes, we can start with the physics-based models for digital twins, but a lot of times we need the AI as well, because not everything can be modeled fully with the physics models. Now, a lot of people are using these digital twins in parallel with the real system, and they want to have redundancy. If something happens in the physical plant, they might use input from the digital twin to move forward and allow the system to be operational. Now, imagine an attacker that will compromise again that AI and will have the opportunity to change completely how the full system is going to interact with the digital twin. We are also using inside Cyberinfrastructure digital twins to analyze the system and to figure out what are the potential attack scenarios. Again, there is that connection between the two words, AI, security for AI, but there is the other angle of the security of using AI. Let's move to the next level, generative AI, right? LLMs, everyone is talking about LLMs. LLMs are used and are going to be used more and more for physical processes as well. You can understand better the processes. We use LLMs, for example, to extract from the specs of a system. So imagine that you have a manufacturing system, we have manuals, we have specs. We can use LLMs to extract models of a particular system, so that then we can do analysis in terms of safety, security, functionality, faults, and so forth, right? But again, there is an opportunity for an attacker to change how those LLMs work so that you get the wrong information. And last but not least, everyone is talking about agentic AI. Agentic AI sounds fantastic, right? You have the ability to define agents that will automate the process. Suddenly you have pipelines that can be repurposed. You can do a lot of things. True, that's fantastic. But how do we do that in a secure fashion? How do we know that those pipelines that, again, have ramifications with supply chains and everything, especially for manufacturing, in such a way that we don't have, again, impact that can be cumulative. A lot of times when we talk about supply chain, we have cumulative effects. If something minor happens in one part of the supply chain, and then at the next level, you add more insecurities, and they add up, or maybe they can be more than that. So all of these things have to be considered when we talk about AI in manufacturing systems, critical infrastructures. We played a little bit with LLMs to create a cybersecurity framework. We have a paper, a cybersecurity framework, and we were trying to understand how easy it's going to be to use LLMs with the different types of data, with text, with specifications of a network, of a manufacturing system, and so forth, and pull all that data and try to do a security analysis. Well, the LLMs were not that useful. We needed the expert in the loop to actually make sense, to extract the context that is relevant. So I think we cannot replace humans. Humans will be there to vet what we are going to get from the AI. But the AI will make the human much faster than it is today. So there will be a benefit, but we cannot assume that everything can be fully automated and we leave the human outside. My advisor had a question 20-something years ago: who monitors the monitor? And I think this is, I keep citing him because I think that was the true thing from 20 years ago. If we want the AI, who monitors the AI, right? We have to have ways in which we can do that. So I'll leave it there.
Well, I just want to jump in and say, you know, when I think about this agent AI work, the first thought I come to was watching my old team do incident response. You know, they're getting data from 90 different sources. They're looking on the network. They're manipulating the network to isolate things. And all of that just screams automation. And an AI offers incredible opportunities for that automation. But at the same time, you need to make sure that having that human in the loop is just so essential. You know, I'm thinking of my last university environment. We had a big health system. Deciding to isolate part of the network where patients are getting care requires more than just coding that into a list. It requires a human going, okay, this is not okay. The risks are really high. Yeah.
So let's pivot just a little bit. So this is a question any of you can answer, but you know, as we are hearing more increasingly about, you know, research security, however one might define that, some of these challenges are increasingly at the intersection of cyber and research security. So, you know, NAIRR, of course, takes into account certain factors that are not just about the compute. So do you all have any kind of practical suggestions about how we could think about bridging this gap between, you know, what's fairly structured for kind of security and compliance and research security, which is a little fuzzy? Any thoughts on how these two can kind of coexist or work together?
I don't think we have a framework at the moment that can tell us what AI is secure to use. And I think that would be important. There is a NIST work that is looking at machine learning. It presents a taxonomy of all the machine learning. But even that document cannot stay up to date easily, right? It has to be updated over and over again. There was a first version in 2024 that didn't have the LLMs. Now the 2025 has the LLMs. The next one will have the agentic AI issues. So what about coming together as a community to build a framework that gives us the ability to test our models? And let's start thinking of how we are going to build our systems that use AI and start from a very formal setting, formal modeling. So let's write down first the requirements. What are the properties that we want? What do we want the AI for? What are the things that we are fine with as risk? What are the mechanisms that then we can use from the classical cybersecurity to deal with those risks that we are fine with? And then having this infrastructure that we could all come together where we can, it's like a playground for all the different types of attacks and testing our models and combining the formal verification with that. I think that would be an amazing type of infrastructure to have for all of us.
Go ahead, Nikolich.
So in the world where I work is with the NAIRR pilot and access, you know, as Anita mentioned, our goal is to support the democratization of science. Our biggest problem right now is who are these people that are using the systems, right? So a requirement of the NAIRR pilot is that the researcher and all the users on the project must be physically based in the US. Prove that, right? We have to trust a lot that this person is who they say they are, right? And I've recently had to report an ORCID profile that this person made up an ORCID profile. There is nothing verifiable on this profile. And we know for a fact they're adding things to their profile that are not true because of being in contact with different parts of the organization. So Access created 8,000 new Access IDs in the last quarter. And our team has to vet so many of them personally to say, and have discovered quite a few that are just completely fabricated identities as far as they can tell. They assume they have some email address from some institution that provides them sufficient access to say I'm affiliated with because I have a .edu at this location. But they're not on the faculty webpage. They're not, so all the ways of doing this are very manual, very tedious. We really need to get it. How do you digitally get this all the way back to a system that says this person showed their face to someone somewhere along the way? And even, I was recently reminded, a Zoom call and a driver's license is something that now can be faked too. So that's getting more and more challenging. So proving these individuals are where they are or who they are, and then also for NAIRR, where they are, is becoming important. And that relates directly to research security, which most of the persons that are of interest are overseas. And so tracking individuals through the systems that exist is definitely a challenging problem that we spend a lot of staff time on keeping track of.
Well, and to follow up on that, everyone came here looking for solutions. I'll give you more problems. We have to acknowledge that we live in a world where academia is desperately trying to keep up with 4 orders of magnitude more resources on the commercial side. And when I was at NSF, I'd go to these reviews for solicitations, and we're giving away N millions of dollars, and it's taking 9 months to make the award or a year to make the award. Meanwhile, I mean, that's not even a rounding error for our corporate overlords, And we worry about a problem like this, but at the same time, I could, agree not to use any of the NAIRR stuff, go work for Meta or someplace for a couple of years, make more money than God, come back. I've just now worked in an environment where there are none of these controls, and I really don't know how we balance this when you have all this activity taking place in a world that is intrinsically ignoring this problem.
So, I mean, how do you think some of these frameworks or compliance should evolve as many of these computational resources really have become or are becoming, whether we like it or not, kind of national strategic assets? Certainly the NAIRR will be a national strategic asset. There's been, since January, Department of Commerce, there's export controls on foundation models and model weights. There's talk now about, restricting kind of who gets chips. So how should these evolve practically as these become not just scientific, but strategic national? Is it more formal verification?
Yes, I will give an example. I'm not saying that that's the ultimate solution, but at Cymeni we have a concept of a cyber-physical passport. So going back to identity is not only about humans, it's actually about parts and everything that is developed. So the cyber-physical passport gives us the ability to track the provenance of parts, and then along that road we can figure out machines, human operators, and designs and everything that follows the life cycle of a part, but also the supply chain, because then you want to know where things are coming from. So we have the ability to track all of that. It's an infrastructure that we've been building and we've been vetting with different industry partners. And it also, it's a superset of the European version of a digital product passport, the DPP of Europe. Actually, Europe doesn't allow products to come out without a DPP anymore because they have a different need for it. They want to make sure that they can show provenance, and they want to make sure that they show compliance. We are bringing the CPP with the angle of cybersecurity, and then we create these big trees of provenance, and then asking a question like, oh, where is it coming from, what entities is involved, what territory, and so forth, becomes quite easy.
So, I mean, how do we see this affecting international scientific collaborations? Most of if you're at a big facility, almost all big science is now internationally focused. Is this good? Is it bad? We just have to figure it out? Or kind of what I guess, Dave and Mike, especially for the science, how do you see this affecting our collaborations internationally?
I mean, it's pretty obvious that it's going to have a chilling effect. I just don't see much way around that. When I talk to, I've heard this now from several of the faculty, research security faculty that I know, they'll say things to me like, oh, all the interesting articles, or most of the interesting articles on AI are now coming out of China. So if you got a situation where some of the most interesting work is coming out, maybe in a language you don't speak, that very few people speak, or at least in this country, and you don't have access to it, it's hard to imagine this having anything but a real dampening effect on the rate of progress in this country, unfortunately.
I was going to say, for the NAIRR and large-scale resources, how do you see, because it affects not just technology, but people, and, many of our faculty in summers, they may not be in the U.S., they may be back with family in China or other countries. So how do you see this affecting instruments like that?
Well, as I mentioned, the NAIRR is required to, it basically eliminates that problem by not permitting international collaboration, at least on the physical resources. Right now, you could collaborate on a paper that refers to the results, but you cannot use the systems physically, or use the digital systems as an international person. So, but yes, I think it does cause problems. Like Access had to implement research security controls for the first time this year at the direction of the NSF to say we're going to start locking this down a little bit. International persons must essentially have to be vetted against the federal lists that monitor research security challenges, and calling them lists is generous. They're compilations on PDF files of things that you need to watch out for that are involve other systems that have to be brought to bear on the problem of just saying, is this person even allowed to talk to our researcher? And it's ultimately, keep in mind, it's not necessarily our problem. We're helping enforce it, but it's the researcher's problem to know who they're collaborating with. So I assume it ultimately goes up to the campuses to say, the researchers need to know who they're working with, and I don't know how the campuses are dealing with that. But our end is maybe a little easier. We can tailor a little bit because we only control who's on the resources, not who they're actually collaborating with, which is the real, problem that they're trying to solve.
But I think this goes exactly to what the people in this room need to be thinking about, is that, we despite the fact that I'll argue cybersecurity is a scaffolding for just about everything a university does these days, or a research institution does these days, it's part of the fun of cybersecurity. You get to stick your nose in everything, and it's part of the torture of cybersecurity is you have to stick your nose in everything. The truth is the idea that you can be siloed as a security professional in this space is nuts. You've got to be on a first-name basis with your export control staff. You've got to be working with faculty in your faculty senate around these issues. And I don't mean just invite them to a meeting once in a while. This has got to be an ongoing, sustained, persistent effort to establish a kind of relationship with the researchers that a lot of security professionals just don't really do.
So what's a good way to start there? I mean, many people in this room are hands-on, they're network engineers, security engineers. They may not even know who does compliance at the university. What's a great way to start for, kind of people in this room to either start thinking about it or socialize this idea with? Where do we start?
I think that's, unfortunately, it's a little idiosyncratic on your institution and the role you're in, but you need to be talking, if you are hands-on keyboard and you're not in a leadership role in your organization, you need to be talking to the people that are in the leadership organization about getting those connections. you know, some of this is, universities are just built of people, and people require relationships. And that means you get to know the people on the faculty senate, and you sort of say, hey, can I come be ex officio on your committee? Can I come present? This is all very basic kind of speed dating for everyone at your organization. This is a level of outreach that many of us have just not done before, many in this community, and need to really start doing more regularly.
So part of this is the culture change. So is it, I mean, Gabriela, you mentioned some great tools for provenance. So part of this, you know, perhaps culture change in scientific cyber infrastructure around kind of new cyber and research security challenges with people using it for AI. What's a good way to, I mean, provenance has been around for a long time, but what's the messaging of like, this is different because?
This is different because we have now many more collaborations that we cannot track anymore, right? There are, again, I was mentioning Hugging Face. A lot of people, maybe here, are using the models from there. But we didn't even realize that there is a possibility for somebody to tag those models. So again, there is a lot of infrastructure out there that we are all using for certain reasons, and we don't know all the different people who can touch that infrastructure. So having a way of figuring out, am I going to use this infrastructure? Maybe I want to see something about it. I want to see a proof for this infrastructure for certain security properties that we really want for our purposes. So sometimes there will be infrastructure that is private because we have more control on it. Sometimes we might go for more community infrastructures, and then we need to figure out the provenance of what is in that infrastructure.
It's probably worth pointing out, even though everyone here has probably thought of this, that it's good to at least inventory or be aware of how much AI you're already using. I mean, every security tool you can buy these days claims to be an AI tool, and it's been this way for a few years. It's just not advertised as much. I mean, do you know where you're using AI, and have you thought about the risks for that? I mean, we saw, what was it, Cisco a week or so ago had some of their core stuff compromised. So you can imagine the opportunities that are out there, the risks that you probably don't have on your risk registers today. And who knows, maybe that can be a conversation opening gambit.
So do you see that as, again, like many folks are very hands-on in this room, is that something where universities, either through CISOs or compliance or auditing, really has to say, you know, we need to do more audits around kind of the models and the provenance? Because I don't know if they're doing that so much these days. Do you see that evolving? I mean,
Far be it for me to say more audits ever to come out of my mouth.
Or what's a good way to get your arms around this?
I would start just by inventorying it, to be perfectly frank.
Yeah, that's true. And we will not have all the answers immediately. Yeah. That's the problem.
A lot of companies that are promising AI really won't tell you much about what's under the hood because they don't want to admit how shaky it is. Yeah.
But there are companies that are combining AI and formal verification as well. So I think that going on that route, I think we will have a little bit more ways to have more transparency, to have more the ability to say more.
But I think the other thing to keep in mind is, you know, I'm reminded of a couple of years ago, I think it was IBM had an ad that said, we now have 64,000 trained consultants in AI. And I was like, 64,000 trained consultants in AI? I was like, that's great marketing. But the reality is especially for people in this room, if you work in those kinds of environments, is to put together a very deliberate course for yourself on how to make up the knowledge gap. When I see the people that I'm impressed by in AI security, they're out of giant companies with very deep pockets, and they have a level of expertise I can barely understand what they're talking about. And so I think people need to recognize that we have a big hill to climb here as a knowledge gap for our community.
So I'm going to push back a little bit. I know there's, you know, you can spend $3 or $5 grand on a prompt engineering certified, whatever. But I'll push back and say some of the people at those big companies that I know who do AI security, fundamentally, they're either really good at network security, like they understand the network, they understand code. They became experts in certain parts of it, but I think it comes down to probably fundamentals still. I don't know if you, or maybe it's evolving differently now with with generations coming up.
I mean, I'll add to that point is what we've learned at the NAIRR pilot is there are lots of people out there who now think they need to be doing AI, but have no idea what that means. So they are applying for these resources. They are using AI. They are trying to train models. So they're at your campuses doing things with AI that they barely understand. So, I mean, there's another knowledge gap for you, and a risk vector for cybersecurity is like there's no telling. They're grabbing miscellaneous models out of Hugging Face. They are trying things that may or may not work, and they want to know, but they don't know where they're at. They don't know how to go from there, and so there's another group that you may consider a potential cybersecurity risk depending on what they're doing and how much access they have on your resources.
Yeah, there is a funny meme. I was trying to look for it and I couldn't find it on my phone quickly. There is a funny meme going on the internet exactly with all CEOs are rushing for AI, and without defining a reason for it or having a real plan. It's just that we have to deploy it today, without necessarily knowing why. What do they need to achieve? What they're pushing their employees to just adopt, and this rush will actually give us a lot of headaches moving forward. I guess we are okay from the cybersecurity perspective. We will have a lot of work to do, but we shouldn't do it like that.
Let me ask one final question, and we'll open up to the audience. So Dave, it seems like NAIRR has done a fairly good job of, and I'll say Fabric as well, my project, of screening people and saying, look, you have to have X criteria to be able to use the instrument. I know culturally there was a lot of pushback on that. NAIRRs may be different, but do you see this, this gets back to research security, do you see that culture changing from kind of funders pushing it, CISOs pushing it, kind of people being just more aware of who's using the resources and for what precipitated the NAIRR kind of stance on this, and where do you see that evolving for other instruments?
So the NAIRR stance came from its origins, right? The NAIRR entity, the NAIRR pilot, was established by a presidential executive order. And the agency, unlike any other NSF project you're on, the agency is in charge, right? They are not awardees, but they are the program management office for the NAIRR pilot. So they have a different standard that they're applying here. And so their guidance from the executive order is that this is open to U.S. Only, the U.S.-based researchers only. So it's a little different, but so the pushback is a little different as well because, well, the NSF said so is usually a good answer for most things, and that's in fact, what happened here. They didn't give that option. And we've not had too much pushback about that, though it is, again, the challenge is confirming it and verifying it. The only other pushback we've gotten from this front is one of the project leads who has to verify that, yes, I am in the U.S. and I will make sure only U.S.-based researchers are in this, wanted to delegate everything about their project once they had it. Like, I want to assign this to somebody else to do all the work. I shouldn't have to be bothered with pushing the buttons to verify that this user is the person I want on this project, and so on and so forth. And I have little sympathy for that. I mean, you're getting this free resource by the benefit of the country, and you can't be bothered to push a few buttons. I have a limited sympathy, but that's the extent of the pushback. But I think that's part of the necessity is, yes, you do. You need to be the one pushing those buttons because you are the person who we are confident is who you say you are. That's the challenge. The only time we get occasional pushback is around those lines where the PI is just too busy. They have lots of awards, lots of activity, and they just are too busy to do the administrative details of granting users access to their project.
So if they don't do that, do they just not get the NAIRR allocation?
They won't get users on their project. They'll have the project sitting there, and if they don't come in and add the users, nothing may get done. But that is their primary responsibility, other than the reporting and other expectations of NSF for the project leads.
So for a lot of years, may I add something? For a lot of years, we've been talking about privacy-preserving IDs, right? Why do I have to show my ID with all my data when I have to prove that I'm over 21 or whatever? During the pandemic, we saw that we have the capabilities to do that with the COVID vaccines, right? With the apps that different big companies put together, we were able to do that. And the tracking and making sure we are not getting sick, whatever. We have the ability to do that. There are companies like Clear. I'm not sure what their technology is there. But what I'm saying is that maybe there is a way in which this problem can be solved in a way that it can be applicable in a privacy-preserving manner.
That goes exactly to the point you were making earlier about the community coming together. Yes. Because my big concern with the privacy-preserving IDs is you're going to end up, this is all going to be run either by an agency I no longer trust or a credit bureau who has all the data already. So I'd love to see the community handle this.
Correct, yeah. Yes. But I think we have examples that it is possible to do it. We can come together as a community to do it.
Yeah, and I mean, on my phone, I have my Colorado driver's license. There are digital IDs that are linked back to your driver's license, which at least you showed up for a picture. You had to show up with paperwork and prove to somebody who you were. So if you could go back to My Colorado, I think is what it's called here, there are apps that the states are starting to recognize the need for this digital identity but linked to their physical processes. So linking all of this back to those would be a start. I'll throw the other wrinkle in, like students throw a whole other mess into this because universities aren't supposed to tell us anything about the students. So how do we verify the students are who they say they are?
That's why we need the privacy preserving aspect. That's why I was mentioning that you have to ask just a question, are they on a US territory? Are they linked to a US organization? You don't have to ask all the other questions that could be a problem. Yeah, I think we should be able to do this.
We got about 15, 16 minutes for some audience questions. So I know there's a microphone there and over there. If folks have some questions, research security, cyber, NAIRR, this is a confluence of topics, but anybody have some questions for these folks?
Thank you so much for this panel. This has really been enlightening. I'm seeing a lot of work being done in research using so-called self-driving labs. So automated, adaptive, scientific processes that learn from each iteration and update and refine their approach. This is happening a lot in synthetic biology and to a certain degree with materials and chemistry as well, particularly. Gabriela, based on what you just described about poisoning models to use more energy to produce inferior output, produce dangerous outputs, given that we're talking about biology and chemistry, how should these organizations who are not, AWS's automated reasoning group and can develop formal models start thinking about this?
Well, that's why I was proposing that infrastructure where they could go at least and learn a little bit more about the models that they are using. They don't have to be expert in the modeling creation. Sometimes they might just be users, but they at least should know what they are getting into when they do that. I was when we were talking earlier, I was mentioning that we had a work where we were showing that with just some simple scratches on an image, you can change the classification of that image. So what if people do that in the real world? It becomes like a physical attack, but then it turns into an AI attack. Let's not forget that there is a way in which people can connect that physical and the cyber world so nicely to reach significant consequences.
So an actual testing resource then, yeah.
Yes, that would be a testing resource. And that would be all of us as a community. We have so many papers in IEEE SMP and ACSAC and NDSS on different potential attacks on AI. What if we come together as a community to create an infrastructure where we can actually integrate all those different attacks, and we have ways in which we can verify that certain models are safe and that we fix the problem and so forth. It would be a humongous effort. Don't get me wrong, but I think it's worth trying it, and then we can all benefit from it.
Love it. Thank you very much. Sounds like a future NAIRR problem, potentially, or maybe?
Well, I'm thinking immediately of the NSF's Programmable Cloud Lab solicitation, which is out now to do just this. So I don't know what their cybersecurity requirements are, but I'm assuming that's not, the problem is close at hand.
Awesome. Thank you very much.
So one thing that the panel talked about was human-in-the-loop things. So something that I've seen a lot in my center is now people are starting to work with AI coding assistants, which gives you the curious combination of this agentic thing that's too big for anyone to understand and can hallucinate, and also possibly lay researchers, maybe even still students, who aren't necessarily proficient in cybersecurity. So I wonder, what are your thoughts on the insider risks that can arise from that?
I have a particular view. I think AI will help good programmers be faster, not to good programmers be better. I'm not sure if that's a good way of putting it. In terms of cybersecurity, I mean. So I think that is not only about writing code, but also verifying afterwards. I think we need frameworks that start from, for generating code, that start from certain building blocks that have been verified. And then from there, you kind of put together bigger parts of the code. But you have to have for example, if you have to establish a TLS channel, that should be like a given piece of code that has been vetted, that has been verified, and that's it. Nobody should write any code on that anymore. I think we have to start thinking of how we limit the LLMs that we are using, or limit the AIs to focus on certain areas on which we also have ways to control the data feeds, and start with the data feeds that are verified to begin with. So building code like that would be beneficial. And again, maybe there are modules that we don't have to write anymore. We write them once and we reuse them as a safe type of code.
So the other way, what popped in my mind when you asked your question was, right now there are no rules around writing software, good software, secure software, period. And in fact, you buy a piece of software and it's defective almost by definition, and no one's liable. You've got to pay to fix it. You've got to pay to monitor it. So, you know, sort of against the background of that, it's a pretty hopeless situation, except it's maybe possible to look at this along the lines of what you're talking about as an opportunity. Because these models are kind of a new horizon to help coders code, perhaps if we tackle the problem you're raising now, maybe along the lines of what you're talking about, we can actually inject into software development some good software development practices that don't exist currently writ large.
Correct. And let's remember that LLMs are trained on code that is buggy as well. It's not only the good one. That's why I'm saying that we have to start with the good seeds of data and have some verification mechanism in the middle. Otherwise, we will end up with garbage in, garbage out.
The community of formal verification of programming is going to be very excited for the hopeful upcoming integrations with that kind of thing. Thank you.
Hi guys, just a quick question. So what we're seeing, or at least what I'm seeing and what we're seeing at the institution level, is that a lot of the AI tools are actually just wrappers. So a lot of it is actually just ChatGPT or just Claude or something like that. And I'm kind of wondering what your take is in terms of, you talked about the fact that the models could be compromised and that there's that security aspect. We're seeing a lot of tools like Zoom and Teams and stuff. They're obviously Teams because it's a Microsoft product, but Zoom is a better example of kind of shifting away from their own AI and integrating more into OpenAI and things like that. So I was just curious as what your take is on wrappers.
could be good, but it depends again how they are used and how they've been built as well. Yeah.
I think in institutions, evaluating, I mean, in industry, they don't do this much better, but evaluating what's under the hood when you buy these tools. I mean, it's different now. It's different than your plain old vanilla security tool. It's now having to understand that it makes calls out to this or does that. So I think in terms of compliance and the legal folks who sign off on the risk, I think they're actually the ones that need to understand, you know, what are the kind of the top questions to ask when somebody's wanting to acquire one of these products. I don't know that they're there yet.
The one other issue I think I've been hesitant to bring up, but I'll do it now because I think it fits with what you're saying. We've been talking about AI security kind of from a practitioner standpoint or a researcher standpoint. The reality is that every single person in your institution is using a commercial AI every day without permission, without license agreements, without any attention to this detail. It's just the new normal, unfortunately, and it's a risk we have to think about as security practitioners.
All right, let's see. Where's the right place to stand? Okay, I think I got it. Hi, I'm Tim from Indiana University. I have a question kind of bringing us back to the very beginning of this panel where, Mike, I think you were the one to give an example of kind of the cause and effect and the rules in physics. And then we see that when we move up to the level of chemistry. And then we get to biology and kind of keep going. And those things we follow that held true from kind of physics start to break down and emergent properties come out. And I think you were kind of equating that to where we are with AI and understanding things. I thought that was a really interesting idea and just wondered if you had more to speak on that or like a source if that came from your head or something I could read more about.
There are lots of people smarter than me. No, I wrote a blog post on this topic on my Substack. But this kind of analogy, though, doesn't really solve anything. It just helps us think about the problem. But we have just as concrete an example in our own history. You don't take your Zeek expert and let him sit down with a developer, usually, and say, explain secure coding. In other words, we started at a level of, you know, sort of classical network security. And then when applications showed up, we required an entirely new, paradigm for thinking about security. It borrows, it learns from, but it's new. And so, this is just yet another level above that when you start dealing with the emergent properties and AIs that can do things we can't anticipate. But no, I suspect Google could probably find people that have expanded on this far better than I have.
All right, well, thank you, and I'll check out that blog post too.
I have two-ish questions that are both basically coming from that point I think Mike made about humility, because I know nothing about any of this, and I feel like every time I look at it, it's already moved far enough that I want to shoot into the future a little bit and hope I can catch up. I think the two things I'm thinking about are, one, I'm interested in what the panel thinks on whether or not AI is going to consolidate into a couple of big models that everyone uses that are pretty general. It's like, oh, there's the Windows and there's the Apple and there's the Linux, and you pick whichever one is your favorite. Or if everyone's going to have their own kind of in-house thing that they tune themselves. So it's like everyone has to, Trusted CI is going to have our own AI model. That's number one. And then kind of unrelated, but I think a point that I'm very concerned about is with the human in the loop. I hear already about, like in law firms, because my background's in law, early level associates, our work is being done by AI now. But those are the future experts who we need to have the human in the loop in the future. And how do we have expertise in 20 years if the current experts are being outsourced to AI?
So I'll just answer the first one real quick. Everybody's going to have a model. I mean, they do that now. You can take Llama and retrain it. Everybody will not have a foundation model, but most companies internally have a proprietary model of their own.
Because they care about their data.
Do we think that's going to be the same in 10 years? I'm wondering if this is like, oh, eventually there's going to be the AI cloud equivalent where everyone starts, off-sorting more too.
No, I think these general models will not necessarily work. Again, whenever we are working in certain areas, right, I think we have to have models that are built for that particular context. And it's important to do that so that we don't have as much hallucination in the model. So I think the using RAGs and using other capabilities that will give us the ability to build models that are really relevant for the context that we need will be key.
Yeah, and I think we're a little fooled by the fact that so much ink is being spilled on the race to bigger and bigger models that only, 8 organizations in the world can afford. When, as everyone's saying, we're seeing these bloom everywhere in smaller and smaller ways, and the technology gets better and better. You'll be able to run really advanced models on, I don't know, the iPhone 29 or something like that. So that too will lead to a proliferation, I suspect.
I think we only got a couple minutes left, so well, thank you, everybody. Thank you, panelists.
Can I make?
Oh, yeah, please.
I have one final comment as from the NAIRR pilot. All of you doing AI related research are welcome to apply. It's open to everyone. However, here's an interesting wrinkle for you all to take back somewhere. If you were to approach the NAIRR pilot with a proposal to do cybersecurity around AI, but we're not planning to use AI yourself, we would not support it because you are not doing AI research. So the important aspect of the work around AI that you may want to explore, you may want to talk to the NAIRR pilot program office yourselves and say this is an important area that needs support through the pilot, because right now we don't support that by the nature of the way it's structured. So thought I'd mention that to this group because it's come up today, but there you go.
Thank you, panelists.